Look around you for a second. A moving car, a glowing light bulb, the hot tea, the food you eat, and even the sound of my voice. What do all of these have in common? They all have involved energy. Energy is everywhere. We cannot see energy itself, but we can see what energy does. Today, using this one diagram, we are going to understand the major types of energy with examples you already see every day. And by the end, I will show you something interesting. Energy can change from one form to another. Now the question is, what is energy? Energy, first, the question is what exactly it is. In simple words, energy is the ability to do work or cause change. For example, you need energy to walk. A car needs energy to move. A bulb needs energy to produce light, and your phone needs energy to work. The standard unit used to measure the energy is joule, written with symbol J. Now let's look at the different forms of energy. Let's start with one of the easiest type, that is kinetic energy. Kinetic energy is the energy of motion. It is the energy of motion. If something is moving and has kinetic energy, a moving car and a running person has kinetic energy, and a rolling ball has kinetic energy. So even the wind has kinetic energy because air particles are moving. Now think about this. Which has more kinetic energy? A slowly moving car or the same car moving very fast? Exactly, the fastest car. So kinetic energy depends on mass and speed. It depends on mass and speed. Sorry for the bad writing. Well, so more mass, a greater speed can mean more kinetic energy. But what if an object is not moving? Can it still have energy? Yes. And that is our next type, potential energy. Potential energy is stored energy because of position or condition. Imagine a holding ball above the ground. Like this, a holding ball above the ground. The ball is not moving. For suppose the ball is not moving. But it has a stored energy because it can fall. The higher you lift it, the more gravitational potential energy it has. Water is stored behind a dam is another great example because the water is high above the ground. It has gravitational potential energy. When that water falls, its potential energy changes into kinetic energy. So remember the simple difference. Kinetic energy means moving energy and potential energy means stored energy. Now let's start discussing the chemical energy. Chemical energy is the energy that is stored in the chemical bonds. Food contains chemical energy. When you eat food, your body breaks it down and releases energy. You then use that energy to walk, think, exercise, and even breathe. Batteries. Batteries also store chemical energy. When you use a battery, chemical reaction inside it help produce electrical energy. And fuels such as gasoline also contain chemical energy. So the breakfast you ate this morning and the battery inside your phone have something in common. Both store chemical energy. Pretty interesting, right? Now let's move to the thermal energy. Thermal energy is related to the random motion of particles in a matter. The particles inside everything are constantly moving. When particles move faster, the temperature generally becomes higher. Think about a cup of hot tea. Its particles have more thermal energy than those in a colder cup of tea. A stove, a fire, hot water, and your warm body all involve thermal energy. And here is something more important. Heat is energy transferred from a hotter object to a colder object because of a temperature difference. Now let's talk about the energy we depend on almost every minute. That is electrical energy. Electrical energy is associated with the electric charges. It powers our light, It powers our fans, computers, televisions, and phones. Lightning is a dramatic example of electrical energy in nature. And when you connect a bulb to an electrical source, electrical energy can be converted into light energy and thermal energy. We'll come back to this idea of energy conversion in a moment. Now, sound energy. Then you're experiencing sound energy. Sound is produced by vibrations. It is produced by vibrations. When something vibrates, it causes particles in a medium such as air to vibrate too. These vibrations travel as sound waves. For example, when you pluck a guitar string, the string vibrates, and those vibrations produce sounds. Speakers, drums, bells, and our vocal cords all produce sound through vibrations. Now, the light energy. Look at this energy. Light is a form of electromagnetic radiations that carry energy. The sun. The sun is our most important natural source of light. Plants use light energy during photosynthesis. Solar panels can convert sunlight into electrical energy, and light from a bulb allow us to see objects around us. So light is not just something that help us see, it also carries energy. Well, now here is the most important idea in this entire lesson. These forms of energies are not completely separate. Energy can change from one form to another form. Take a flashlight. The battery stores chemical energy. That becomes electrical energy, and the bulb changes electrical energy mainly into light and thermal energy. Well, what am I saying? Trying to say that chemical energy of flashlight is getting converted into electrical energy. And that electrical energy is then converted into light plus thermal energy as it is producing heat. So, when you eat food, the chemical energy inside your food converts into movement and plus thermal energy, and so on. But does energy disappear when it changes form? No. According to the law of conservation of energy, energy can never be created nor be destroyed in an isolated system. It can only be transferred from one form to another form. Now let's revise everything. Kinetic energy, energy of motion. Potential energy is the stored energy due to the position or a condition. Chemical energy is the energy stored in a chemical bonds. Thermal energy is related to the particle's motion. Electrical energy is associated with the electric charge. Sound energy is produced and carried through vibrations in a medium, and light energy is the electromagnetic radiations that carries energies. So different forms, but all are the forms of energy. Now here is your challenge. When you switch on a fan, which energy transformation takes place? Think about it and write your answer in the comment. If this lesson made physics easier for you, subscribe for more science explained simply. Thank you.